r is equal to the 6 sine 2 theta. So let's try here and let's work with this. But first of all, let me denote into this point here between pi over 3 and pi over 6 is a pi over 4. So this point here is a pi over 4, this line. So let me write here with a pi over 4. So I'm writing here pi over 4. So this line here is a pi over 4. And now I wanted to construct the figure, whatever we get from this equation. We want to graph this equation. But first of all, let's see, let me take the 0. If I have this equation here, and if I plug in instead of the theta 0, 2 times 0 is 0, and sine of the 0 is 0, and 6 times 0 is 0. So this point is going to be here when it's a 0, okay? Now I'm going to see, maybe I cannot take a different color with a black color, okay? And now I'm going to take a theta when it's a pi over 6. If I'm plugging here pi over 6, but 2 times pi over 6, 2 with a 6 we can simplify, and this is pi over 3. And if we get the pi over 3, so just let me go in calculator here, let me do some quick calculation. If I'm plugging here pi over 3, okay, so let me see, is in the rad, okay, and pi divided by 3. I divide by 3 and I'm going to see the sine, what is going to be. The sine is a 0.866. We already know this is the square root of 3 divided by 2. But now, since we have this value here, then we multiply by 6 because we are calculated just sine 2 theta. We have this value. If we are multiplying by 6, we have this value 5 let me round to the nearest that two decimals, 5.20. So 5.20, so I have this here, and this is a 6, 6 is here. So this point here is a 6, and this one is going to be 5.20, let's say is approximately here. So I'm sketching this point. It's not in the scale, but I hope this is we are very, very close to 5.20. And now we are going to look for pi over 4. But look here, 2 times pi over 4, 2 pi divided by 4, because it's 2 here. If I am substituting theta by pi over 4, this 2 is going to simplify by 4 and is going to be pi over 2. But the sine of pi over 2, we already know this is a very easy to know because the sine pi over 2 is 1. And 1 times 6, so just the sine 2 theta, in this case when I'm substituting theta for pi over 4, is going to be 6. So this is equal to 6. And 6 is here, this point, 6. And if I'm going here for the pi over 3, we get in the same thing because instead of the theta, I am applying a pi over 3. And the pi over 3, it turns out to be 0.866, what we looked at before. And now what's going to happen here, if I'm multiplying it, we're going to get to the same value, 5.20. And 5.20 is here somewhere. Okay, if I'm going in a pi over 2 here, and 2, we are substituting pi over 2 instead of the theta, what's going to happen here, 2 pi divided by 2 is just pi, but the sign of the pi is a 0. So 6 times 0 is 0, so it's going to be here. So this is going to be like a petal. So this form is going to be something like this. Okay, maybe I'm not drawing very good. I'm trying to do my best. So this is what we're going to get here. But this petal is going to repeat everywhere because when we have a 2 pi over 3, we are going to get to the same value what we got here in a pi over 3. And this value here, so just let me denote with a different color. This here is going to be 5.20, so here somewhere. But what is the value here in this line? In this line is, let's say here is a pi over 4. And 2 pi over 4 is here, and here is 3 pi over 4. So let me write here 3 pi over 4. But in a pi over 4, we already have this value. It was a 6. So this is going to repeat in each quadrant. And now, for example, if I have 5 pi over 6, we already found this value was a 5.20. Okay, but when we are going in the pi to substitute here, is going 2 pi, but the sign of 2 pi is a 0. Again, is going here. So we have a second petal here. And this second petal we can we can draw. I hope this is going to be something. Okay, so this is going to be something like this. Okay, so it's not great, my handwriting, but I hope I am making the point here. Okay, so this is going to be something like this. Second petal. Again, if I'm going in the third quadrant, but now I'm looking for this line here. So let me find this line because it's not denoted with anything. Here is 3 pi over 4. And if I'm going for 45 degrees, here is going to be 4 pi over 4, which is a pi. And this is going to be 5 pi over 4. So this point here. 6 pi over 4. And here is a 7 pi over 4. So this line here is a 7 pi divided by 4. So this line here. And now we have everything. Now I'm going the same things. Whenever we have with a pi over 6, is a 5.20. So this point here. Whenever we have a pi over 4s, we have a 6. So this value. Pi over 3 again is 5.20. So we already have this one. And in a 3 pi over 2, so this 2 pi, 2 is going to be simplified by 2. In 3 pi, sine in 3 pi is going to be 0. So again, we are going to get the same pattern, the same values. And this one we are going to connect. This here, this petal. And we are getting the third petal. So we are getting a beautiful petal. I think we are doing in graphing utilities. Probably this is going to look much better than what I'm drawing because I am not a very good artist. So now let me go to the next quadrant, to the quadrant 4. In the quadrant 4, we have a 5 pi over 3 already here. As I said before, in the pi 3 and a pi 6, we have here pi 6. So it's going to be something like this. And 7 pi over 4, whatever is associated with pi over 4 is going to be 6. And if we are going in the 2 pi, time 2 is a 4 pi, and the sine of our 4 pi is a 0. Again, we are going to the same point to go, and this pattern is going to repeat. So let me do this with a blue color. This pattern repeated and goes through these points and closes. So this is a beautiful flower that we can get with the equation, with the polar equation that is r equals with 6 sine 2 theta.